Now, let's talk for a moment about fusion weapons. All right. Fusion weapons use the energy from a fission bomb to cause a fusion reaction. And unbelievably, to me anyway, it's basically the pressure of light, very high frequency light, X-rays, that crushes the fusion material and sets off the fusion reaction. Now, a modern thermonuclear bomb is actually an incredibly complicated series of reactions. So bear with me for a minute while I describe this. So first, you have what's called the primary. This is the fission bomb that's going to trigger the whole reaction. Now, the Nagasaki bomb was a solid ball of plutonium, basically. What we do these days, in order to make it more efficient, is we have basically a hollow shell of plutonium. It's a ball, but it's a hollow ball. And so then the explosives can crush it much more before it becomes supercritical. Okay? Now, one of the things they figured out that's clever in order to make these fission bombs more efficient is to turn them into a fission fusion bomb. This is what's called boosting. Okay? So what happens is they put a little bit of tritium and some deuterium gas into the middle of this hollow core. Okay, the explosives crush the hollow core, just like in the Nagasaki bomb, except, of course, we've gotten a little bit better in designing the explosives since then. And that sets off the fission reaction. So we have temperatures of hundreds of millions of degrees, incredible pressures and so on, and we have this tritium and deuterium gas in there. And the temperature and pressure get to the point where that tritium and deuterium fuse and make helium. Okay? And that sets off a big shower of neutrons. So those neutrons then fission more of this plutonium. Okay, so so a typical primary today, you might have, if you neglected to have any tritium or deuterium in it, you might only get, say, 2 kilotons of yield out of it, 3 kilotons, 4 kilotons, something like that, whereas you might get 20 kilotons out of it with the boosting. Okay? So it's not like you'd get nothing without the boosting, but you'd get a lot less without the boosting. Okay, so then you have all of the energy from, say, 10, 20, something like that, kilotons, and that then there's a complicated design that ends up focusing the X-rays from that on this. And it crushes this down. And what you have is a compound called lithium deuteride. And this is so you don't have to keep having tritium gas and deuterium gas around all the time in this part of the weapon. The lithium ends up splitting, so you end up again with basically a fusion reaction of different hydrogen isotopes happening. So you have, this is the fusion fuel. So it gets crushed, the lithium gets split, and then it gets fused, and that then releases another shower of neutrons. And just for extra oomph, you put some uranium around that other shower of neutrons. So then you end up with a fission reaction causing a little bit of fusion, which causes more fission, which causes fusion over here, which then causes more fission. It's a complicated bomb. But basically, you can adjust, depending on the design of the weapon, how much of the total yield is coming from fission, how much from fusion. As a typical thing, you might have sort of half and half coming from each. But with this kind of a weapon, you can get to dramatically larger explosive yields than you can with fission by itself. So the largest all-fission weapon that the United States ever made was, I think, about 200 kilotons. Whereas, we used to deploy a 9 megaton. I should explain kilotons and megatons. Kilotons means the equivalent of 1,000 tons of conventional explosive is a kiloton. In the class that I teach, I have the students do a calculation of how long a train carrying explosives would have to be to carry as much explosives as the Hiroshima bomb. I think it's, if I remember correctly, it's 3.2 kilometers of train carrying explosives to have as much as the one bomb at Hiroshima. It really is an amazing quantity of energy. But when you're talking about thermonuclear weapons, you can go up into the megaton range. The biggest nuclear weapon ever detonated was in the Soviet Union in, was it 61 or 61 or 62 or 63, somewhere right in there. It was 58 megatons. And it was actually designed for 100 megatons, but they just dialed it down because they didn't want to do as much damage in the test. Even as it was, there were trees blown down, you know, many, 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 many miles from the test and so on. So that's fusion weapons. If anybody has questions, you should stop me.
And yeah. This is the Soviet design is the same concept.
Basically the same. Yeah. Yeah. I mean, there were kludgier designs, especially in the United States, before. I mean, the first thermonuclear weapon the United States built and detonated was more or less the size of this room and had like refrigerators and stuff like that. And it was really not a practical weapon. All right.